The simulation and experimental data of drying kinetics are depicted in the figure 2. Uh, this pressure follows two regimes. The active regime, in which the vacuum pump is operating, whereby the pressure in the chamber decreases, and the passive regime, in which the pump stops working since the chamber is at the required vacuum pressure. This behavior is explained by the fact that the vacuum drain does not remain at constant pressure. Simulate vacuum drain kinetics showed a good agreement when compared with the experimental data. The figure 3 shows a drying rate as a function of the moisture content and the average temperature of the sample. In this figure, it's possible to identify three phases. The first one is a period of heating where the drying rate increases. The second corresponds to a period of the constant temperature, and this one, where the drying rate decreases smoothly. The last period revealed an important decay of the dry rate due to the difficulty to remove the bone moisture. Then we observe a fast heating period of the solid. Uh, the constant vacuum drying of potato was simulated by considering the dynamic of the dry in his passive and active phases. Drying kinetics showed a good agreement when compared with the versus experimental data obtained by Fallow and Boudra. The frequency of the active and passive phases depend on the mass flow, then the increase in the capillary region where free water is more abundant, and the frequency decrease in the hygroscopic region. We observe three periods of drying in a short heating period. The drying rate increased after that period of the constant temperature was identified, where the drying rate decreased smoothly. Finally, in the last period, abruptly decreased the drying rate is displayed. The driving force of the water evaporation is the difference between the gas pressure in the chamber and the vapor pressure at the surface of the food. The proposed boundary conditions allow to simulate correctly the drying kinetics and the heating phase and the heating and gas pressure evolution in the drying chamber. Thank you very much.